We have these transfer functions that we see on the screen, and we are going to go to MATLAB and test them to see whether they are whether we can obtain their body plots. The body plot implies that we have an input frequency here and an output frequency over here. And what we are trying to do is to see, to obtain a plot that will plot the input. Let's say we put the signal input like this. We want to see that the output, it should be the same signal, but chances are that the output is not going to be the same in the same way, that the output may be a bit out of phase, something like that. And what we are after is we are going to plot make a couple of plots that where this is scale, where you have this is 10 to the 100, then we, for each frequency we input over here, we want to see two things. We want to see what the amplitude is, you know, of the frequency of this plot. This might look something like this, maybe, and or you may have a. So this would be for the amplitude. So this is the amplitude of the signal. But right here you can see that the output may not track the input, and this we call the phase angle. So this might have something like this. So where this would be plus, let's say, 90 degrees or minus 90 degrees, or you have this, so this would be the phase angle. This is the angle here. Okay, so what I propose is let's go to MATLAB and enter this transfer functions in there and see. So 1 over s plus 2 is the first one that we're going to do. And so we go over here to MATLAB, and let's make this big so that we can see it very clearly. And then we have this. Okay, very good. And so in here we have, we're going to see that let's define S equals to a transfer function type of definition for the S character. So this is a transfer function. So I'm going to put G1 is going to be equal, what do we say, 1 divided by S plus 2. Yeah, this first order system. There we go. Right here we can do several things. You know how we did, we tested the with the step and with the body plot, and we also now we're attempting to do the body plots. This is simple. You say body, and then you say G1, and then you return, and guess what happens? Computer will go and give you those two plots, you see? The magnitude and the phase angle. Of course, the x-axis is the frequency in here. Yeah? So this is a simple body plot. I mean, needless to say, once you have the transfer function in here, you can do other things. You can do a step input with G1 like this. Sorry, I didn't have G2. Do we have G1? And this would be the response of the system. And then if you have the you could do the impulse. These are important because I may ask you on your next on the exam or to I already have. It's just that practice here. See, this is the impulse in here, or we could also do the root locus. So we can do all these things once we have the transfer function. See here, like that. Very good. So now I'll just reminding you on the emphasis of today's lecture is on the body plot, this one. Okay, we had another one. This says s over s plus 2. Let's see how that changes, okay? So we are going to go and do MATLAB again. And we're going to say now G2 is equal to S divided by, what do we have? S plus 3, right? I think we could have used the denominator from before, but I mean this is my new transfer function. How does my body plot looks like on this body of G2, like that? And we're gonna go over here. This is how it looks, this new body plot. Okay. And here you can see that it starts with the magnitude that doesn't match the input, to 1. There's no, I mean, this has an amplitude 1 and it's 0 amplitude in here. Here's 90 degrees and then 0 degrees here. This is, so we use this to study the control systems here. We are going to look at the third transfer function, which would be let's see, where are our notes. What about G3? Let's do G3. Here we're gonna put another. We're gonna put. Let's put a 0 here. So let's see, s plus 2. Yeah, divided by s plus 3. All right. So what do? We go over here, and then we're going to do the G3 is a transfer function, and I think the best thing is to make it very clearly. This is s plus 2, like that, divided by the denominator, which would be s plus 3. And then you have this. Here's we have the transfer function in here. I want to make sure that we don't have plots yet, so we can actually see it firsthand. So we say body of G sub 3, like this. And where is my plot, my figure? There you go. Okay. So the conclusion is, giving a transfer function, we can obtain a body plot just by these simple steps using MATLAB. We have to have the transfer function in this case. But if we don't have the transfer function, that's where the CAMG and the bond graph modeling technology comes to your assistance. Because right here we started at the transfer function level, but you have to have it. And if you don't have it, you have the system, then you make a bond graph model, and then automatically you could actually produce this transfer function that you have, and then do these body plots automatically. So just as a simple example, we could try a very simple bone graft model system as we have done in the past, and you'll see that we'll end up in this real quick. We don't have to have the transfer function to do that. So let's just go over here and give you an example like that. And then we say, here we go to the CAMG software here, right here, and then we go over here, okay, and we say, okay, we are going to we are going to do a new file, say new, and just if you enter a simple example like a spring mass system, that would be have a bond graph model like this, where you have an I element, and then you have a C and an R element like this. Okay, just to make it simple. Okay, this is a system of a spring mass system. Okay, so right now, for doing the transfer function, we have to have an output. So we're going to say that E sub 3 is the output. Okay, and SE1 is the input. So in here, if you go here and you go to MATLAB, and then you get the CAMG and the MATLAB interface. Right now we had a bit of a mess up on the automatic interface, so we are going to go to the where those files are. We're gonna go and open them up from where we know where the system puts those files, and that is going to go to this drive here. CAMG puts in the CAMG working file, and we are looking for this file, the CAMG SYM file, which is the symbolic file. Let's see, so that we this one right here. All right. So what's gonna happen now is that this file that CAMG produces has already all the yeah. Excuse me, CAMG SYM. We need to have it displayed. Right here. All right, there we go. So in here, we're gonna go and say, okay, look for the this was E sub 4, right? The output is E sub 4. So what we need is we need to define the output, because the system does not know what outputs that you want, but it actually prepares all the possible outputs in the bond graph model, and then you have it like this. See? And if you run this, you're going to obtain the transfer function immediately, and of course you will get the state space form as well. But what we are after is obtaining the transfer function right here. There you go. This is the transfer function. The point is that in here, if we give numbers, you can obtain not only the root locus but also the body plots. So let me show you this. If you give numbers to the physical parameters, and let's say just for the sake of example, you put this as make it a 2, just to make it this 1 over 30, which usually works, and let's do this a 5. Those are reasonable numbers. Okay, and if you do this, and here we say Control C, and then we go and start this. Guess now these are numbers, and you get your transfer function in numerical form. The computer at this point goes and looks for all the tools in MATLAB to give you your body plot automatically. It gives you also your root locus plot automatically, and automatically will also give you the other plots that we know of. Like in here you have the impulse response, and you have the step as well, see, and you have your body and your root locus plot, all automatically without having to enter those into the MATLAB.